Mal and Honey Jane L, and today we're going to discuss our panel discussion, which is titled of Understanding the System of Linear Inequalities and Linear Programming. But for now, we have a two lesson, which is the lesson 1 and the lesson 2. But first, the lesson 1 title is the System of Linear Inequalities. But first, we have the theme. The theme is the solving of the system of linear inequalities to its graphing solution, and we have the objectives. First is to analyze the full concept of the system of linear inequalities, and the second, to understand the step-by-step procedure to finding the solution of the system of linear inequalities, and lastly, to determine the overlapping region where solutions to all inequalities exist. And the lesson 2 title is Linear Programming, and the theme is to solving the intercept of linear programming and the objective function in its graphing solution. And we have the objectives. First is to maximize or minimize a specific objective function, such as maximizing profits or cost in a given state of constants. The second one is to develop skills in solving complex and real-world problems involving resource allocation, production planning, transportation, or inventory management using a linear programming techniques. So, without further ado, good day everyone! Welcome to our panel discussion on understanding the system of linear inequalities and linear programming. I am excited to introduce our esteemed panelists who bring a wealth of knowledge in mathematics and its practical applications. By the way, I am Mal and Hannah Jane L, your host and your moderator of the day. Please join me in welcoming our panelist number 1, Marana Francis, our panelist number 2, Makaskas Ramirez, our panelist number 3, Masangkay Renwell, our panelist number 4, Nasara Kim J, and lastly, our final panelist, Medico Christian Joy. So, let's proceed in our reviewing of systems of linear inequalities and linear programming. To set the stage, let's hear us first from Mr. Marano Francis, our panelist number 1. So, what can you say about the system of linear inequalities?
Is a set of two or more linear inequalities with the same variables. The solution to a system of inequalities is often an infinite set of points that can be represented graphically by shading.
Thank you, Marana. Let's proceed to our second panelist, Mr. Makaskas Ramirez. Can you give us an overview on how to solve a system of linear inequalities graphically?
Good day everybody, my name is Rimas Makaskas. Okay, so in solving a system of linear inequalities graphically, we gotta need to remember these procedures. Firstly, solve the inequalities for x and y. And then secondly, treat the inequalities as a linear equation and graph the line as a solid line or dashed line, depending on the inequality signs. If the inequality sign does not have an equal sign, then draw a dashed line. If the inequality sign does have an equal sign, then draw a solid line. Thirdly, shade the region that satisfies the inequalities. And then lastly, the solution set will be the overlap region of all inequalities. And that's how you can solve a system of linear inequalities graphically.
Thank you for that articulate explanation, Mr. Makaskas. Now, let's proceed to our third panelist, Mr. Masangkay Renwell. What is your take about linear programming?
Good day everyone. Linear programming, a mathematical modeling technique in which a linear function is maximized or minimized when subjected to various constraints. This technique has been useful for guiding quantitative decisions and business planning, industrial engineering, and to a lesser extent in the social and physical science.
Thank you for that answer, Mr. Masangkay. Now, let's move on to our panelist number 4, Nasara Kim J. Nasara, can you enumerate the 5 characteristics of linear programming and in your insight about them?
So, first of the 6 linear programming in the mathematical technique automation is linearity. The relationships among the variables in the objectives function and constraints are linear. This means that each variable has a coefficient, and the overall expression is a linear combination of these variables. Number 2. Objective function. There is a specific objective function that needs to be either maximized or minimized in a function that is a linear combination of decision variables and serves as a goal of the optimization. Number 3 is constraints. Linear programming involves constraints that restrict the values of the decision variables that can take. These constraints are also a linear expression forming a sister system, linear inequalities. Number 4 is a non-negativity. Decisions variables must be non-negative. This means that negative values for decision variables are not allowed in the feasible solutions. Number 5 is additivity. The total contribution of each decision variables of the objective function is the sum of the individual contributions. This principle allows for breaking down complex problems into simple parts. Number 6, the last characteristic is divisibility. Decision variables can take any real value, including fractional values, and this characteristic allows for flexibility in finding optimal solutions.
Our final finalist, Mr. Medical Christian Joy, do you have any examples about how you can solve a linear programming?
So yes, I have an example of how to solve in linear programming. To solve in linear programming, make sure you have an objective function and constraints. So each constraint has to find the 2 intercepts, which is x and y. So if you want to find the x-intercept, the y value of the expression is always 0. You can solve it until you find the x-intercept. Second is the y-intercept. If you want to find the y-intercept, the x value in the expression should be 0. You can solve it until you find the y-intercept. So after that, you can solve the objective function based on the 2 intercepts in the program.
So now let's go on to the question and answer portions with our panelists. What is the significance of the solutions to a system of linear inequalities in real-world scenarios? Can you provide an overview, Mr. Morano?
The solution to a system of linear inequalities guides real-world decision-making by identifying valid options that meet multiple constraints, ensuring practical and feasible outcomes.
Thank you for explaining the significance of the system linear inequalities in real-world scenarios, Mr. Morano. Mr. Macascas, explain the concept of a feasible region in the context of a system of linear inequalities.
So the feasible region in the context of system of linear inequalities is a set of points that simultaneously satisfies all given inequalities. It represents the region where the conditions imposed by all inequalities overlap.
What a wonderful answer, Macascas. Mr. Nasara, do you have any technique that you can share to use to solve a linear programming problems and when it is appropriate to use each one of them?
Thank you, Ms. Malan. So the technique that is usually used in the graphical method, this method is used to solve small-scale linear programming problems with 2 or 3 variables. It involves graphing the constraints as lines in a 2 or 3-dimensional space and finding the feasible region where all constraints are satisfied. The optimal solution is the point in this region that maximizes or minimizes the objective function.
We're getting there, everyone. Thank you for answering, Mr. Nasara. And lastly, the panelist number 5, Mr. Medical Christian. Question for Mr. Medical: how to solve and graph a linear programming problem?
So to graph in a linear programming, make sure you first to solve the constraints. So after that, you have 2 intercepts of each constraints and draw a Cartesian plane. And after that, you can plot the 2 intercepts in the Cartesian plane and connect it using a solid line.
Thank you so much for that information, Mr. Medico. In addition to that, as a moderator, linear programming involves a linear relationship and it is typically solved using a graphical method of two variables. Thank you, panelists, for sharing your insights. Our discussion today has shed a light on a practical application, challenges, and future possibilities of the system of linear inequalities and linear programming. Until next time, stay curious and keep exploring the world of mathematics.